Okay, let's try this bomb calorimetry problem here. So this is number 35. We have naphthalene C10. H8. 1.620 grams. It's burned, completely burned, that's a combustion when it says burned, in a bomb calorimeter. And the temperature change is 8.44 degrees C. So there's a delta T increase of 8.44 degrees C. So that's the delta T. If the heat of combustion of naphthalene is negative 5156 kilojoules per mole, so we have the heat of combustion of negative 5156 kilojoules per mole. I want to know the heat capacity of the bomb calorimeter. Okay. Well, sum of the Q's equals 0. So there's the Q for the reaction. That's this thing right here. And then the Q for the calorimeter, the bomb calorimeter. So Q reaction equals negative Q cal, which is negative C delta T. And one thing you want to remember when we're doing the bomb calorimeter, they like to lump that MCP, mass times specific heat, into just the C term, which they call the heat capacity. And I think that's basically what it wants you to find, what is the heat capacity. So you can see it's kind of a, once you get to this point, you just got to plug it in correctly. C is minus Q reaction over delta T. We'll have to do a couple conversions, but we've essentially got it. The conversions we'll have to do is with this. Yeah?
Just a quick question about heat capacity and like that kind of terminology.
Yeah.
Are CP and CSP both specific heat, and then C is heat capacity?
Oh, okay. So, side note, heat capacity, specific heat. Depends what book you're reading. So in some books, heat capacity is C, and specific heat, like I'm using right now, specific heat is CP. On other books, to make things as complicated as possible, this is CP, and this is CSP. So for example, I think your lab manual uses this bottom one, but I believe the textbook uses the top one. So hopefully that doesn't make you too crazy, but CSP definitely is the specific heat. In which case this would be the heat capacity. Okay? So somehow figure that out if you can. Q reaction. We have to do a couple things. This is per mole, but I'm not doing this per mole, I'm doing it per gram. So I've got to convert to the correct grams. So C is minus delta Q reaction over delta T, which is minus Q reaction 5156 kilojoules per mole. I need the molar mass of this to convert to grams. So let me look that up here. I think it's listed. 128.2. So you'd find that from the periodic table. 128.2 grams per mole for naphthalene. And then there's one more step. I need to multiply by the given mass. 1.620 grams. And delta T on the bottom, 8.44 degrees C. So what I did in the numerator there on top is a very typical conversion type problem, where I have to convert, and often you'll have to do that, because they'll give it you per mole and they want it per gram, or vice versa. It's per gram and they want it per mole. Okay, when you do that mess, you're going to get 7.72 careful of your units here. They didn't require a specific unit in this question, but it's going to be kilojoules per degree C. So be careful of that kilojoule, joule thing. Here's kilojoules, sometimes you want joules, whatever. Okay, well, welcome. I'm going to stop the camera. Next question, does that help you out?
Yes, thank you.
Okay, next question.